Hello, everyone. So we are gonna write an equation of the graph given. So this is a graph for the rational function. So if you remember, the parent function for a rational function was y equals 1 over x. And then this was the basics one. So it was going through 1 comma 1. And then this is our like y-axis, and then this is x-axis. Actually, this is x-axis and this is y, so which is why I have to choose the correct place. So, this is the y-axis, this is x. So that was something right here, and then you were getting the graph, something like this, right? And also that was passing through -1 comma -1. So it looks like it was right here. So it was, again, it's not perfect, but at least we remember that the equation for the y equals 1 over x was something like this. So this is passing through 1 comma 1. Okay, and then this is -1 comma -1, and then this is your origin. So I just draw this just to remember them. So we are gonna use the transformation or effect of these parameters. So the A is our vertical dilation, and then K is vertical shift, and then H is horizontal shift, right? So, but we are given some like line, the horizontal asymptote of this graph was x equals 0. Horizontal asymptote was the number, right? X equals 0, which was making the denominator 0. But now, if you look at the graph that we are given, so this line, graph and this graph is approaching to this line, which is passing through x equals +1. So my graph has the horizontal asymptote as x equals +1. But what does that tell us? Like it was 0, now it's 1, which is a +1, which means we just move this uh, asymptote to the right by 1 unit. So that means h has to be our answer for the horizontal asymptote. So I'm going to write this as horizontal asymptote. So this is equal to x equals 1. So which means h is 1. Okay, so that is something. So 1 over x minus 1. And also, we do need to find the vertical asymptote, which is one of the easiest one. In the original function that we had, the vertical asymptote was this line, which is x equals 0, right, for this function. But now this line moved 3 units below, right? So now this is going to be y equals -3. So that means k has to be -3. So you just move that 3 units below. But how about a? So I'm going to write this a times this fraction, and then this is equal to our y value or g of x. So there are a couple of ways to get the a, but the first thing that we probably realize, this graph and this graph doesn't look like the same orientation. So meaning that if you were to reflect this over the x-axis, then you do get actually something similar to this one, but you're gonna move it a bit downward for sure. And then if you reflect this one over this axis, you will get something like this, which is similar to this one. So meaning that this A has to be negative. Otherwise, the red graph that we have for the parent function doesn't look like this similar to the blue function that we are given. So which is why that needs to be negative. But we can actually take that kind of idea, but just to prove it by plugging one point. So if I just choose, let's say this point 0, -1 and plug in this equation, I should be able to get this A. So let's go ahead and do that. So if I choose x is 0 and y is -1, so you will get -1 equals A times 1 over x is -1 minus 1 minus 3. So if you add 3 to both sides to cancel this guy, so you can add 3 to both sides. So you get -3 plus -1 plus 3, which is 2, equals a times 1 is a over the denominator is -2. If you multiply both sides by 2, did I miss anything? So that was that. So actually x is 0, so that is wrong. So this was 0. So let me clear this. So the x is 0, which is I choose, and -1 and -3. if you add 3 to both sides, so you get 2 equals a times 1 is a over -1. If you multiply both sides by -1, a will be -2. Then we are actually done. So the question was asking the graph, so which is this way, and the g of x is equal to a is -2, so that is -2 times 1 over x minus 1 minus 3. And that is the graph of this blue ones. Okay, I hope that makes sense. We just use the some of the key points of the parent function and see what changed. And then based on the vertical and horizontal asymptote, we were able to get h and k easily. But after getting those two, we have to find the a as well, which is like some sort of dilation. In this case, that is -2 by plugging the one of those points. If you were to plug this 2, -5 in this equation, you should be getting the same a value as well, which is we can try as well. So if you were to plug 2 for x and y as -5, so you will get a times 1 over a is 2, so 2 minus 1, and that is -3. If you add 3 to both sides, so you will get -2 equals a times 1 is a divided by 1. So as you see, a is still -2. So you could just plug this number or this like point or this point to get your a. So either way, you will get the same result. But I want you to see something else as well. You know, in our original like function, which is this parent function, the distance between the one of our reference point, which is 1, 1, and the x-axis is 1 unit, right? This is 1 unit. And look at our second graph. So after like we did some sort of transformation, this is my horizontal asymptote, and then this is my one of the part of the graph. And the distance between the horizontal asymptote and that like reference point is twice as much, which is 2 units. Like, does this have to do with this number too? And I will leave that for you as a challenge. And I want you to kind of try maybe drawing different equation or just like draw this on a decimal or somewhere else and change the a's and see what's gonna change, and then change a 1 to 2, 3, 5, and some negative values, and see if this difference, I mean this distance, somehow related to this distance, and then I'll leave that for you to explore. Okay, so I hope this makes sense. I'll see you in the next video.